So if you work with data, I'm sure you've heard this a million times. You should learn to code. But let's be honest, the world of programming can feel kind of complex, maybe even a little mysterious. Well, today, we're going to pull back the curtain and show you what it's really all about. But first, let me ask you something. Just imagine for a second, what if you could tackle a data set with millions of records and do it with the same ease as you would with a small spreadsheet? It sounds like a fantasy, right? Well, that's exactly the kind of power we're talking about today. All right, so let's start with the big picture. When we strip away all the complicated jargon, all the tech speak, what is programming really? At its absolute core, programming is surprisingly simple. Seriously, the best way to think about it is like a conversation. It's just a process of giving a computer a set of very specific, step-by-step instructions to get something done. That's it. There's no dark magic involved. It's all just about clear, logical communication. Okay, but here's the catch, right? Computers don't speak English. So how do we have this conversation? Well, we use something called a programming language. Think of languages like Python or R as a translator, or a bridge that connects our human logic to the computer's world. They're just the structured vocabulary we need to give instructions a machine can actually follow. And here's the really cool part, the thing that makes this whole world way less intimidating. It doesn't matter what language you use or what problem you're trying to solve. The fundamental process is always the same. It really just breaks down into 4 core steps. So it all starts with problem solving. You take a big goal and you break it down into tiny logical steps. Next, you translate those little steps into code. Then comes the fun part, execution, where you tell the computer to follow your instructions. And finally, the part everyone talks about, debugging. That's just finding and fixing any little mistakes or bugs and making your code even better. It's a cycle. You think, you write, you run, and you refine. Okay, so that's the what. But honestly, who cares about the what without the why, right? Why should you, as someone who works with data, even care about any of this? Because, my friend, this is where programming stops being a concept and starts becoming your own personal superpower. For anyone in stats or data analysis, programming isn't just another skill to list on your resume. It's a way to take complete and total control of your workflow. It lets you automate all the boring, repetitive tasks so you can focus on what actually matters, analyzing and interpreting your data with incredible speed and depth. Just think of it like you're building out your ultimate data analysis toolkit. Programming gives you these amazing new tools in 5 key areas: managing your data, running complex statistical analyses, making sure your work is reproducible, creating awesome visualizations, and the big one, scalability. Let's be real for a second. Real-world data is almost never clean. You know what I'm talking about. Missing values, duplicate records, weird formatting. It's just a mess. With programming, you can write a tiny script that cleans up millions of rows in seconds, a task that could literally take you weeks to do by hand in a spreadsheet. And that automation leads directly to one of the most important ideas in science, reproducibility. Think of your code like a perfect recipe. Anyone, your colleague, a peer reviewer, or even you 6 months from now, can take that recipe, run it, and get the exact same results every single time. This is the bedrock of trustworthy science. And that brings us to scalability. Remember that very first question I asked you? This is the answer. A spreadsheet might start to choke on 100,000 rows of data, and we'll just give up with a million. But a simple bit of code? It can handle millions, even billions of records without breaking a sweat. For anyone working with big data, this isn't just an improvement, it's a complete game changer. All right, that's enough theory. Let's make this real. To see how this all works in practice, we're going to take a super simple everyday task and see exactly how we tell a computer to solve it. Our goal is as simple as it gets. Find the average of a list of numbers. Now, we all know how to do this in our heads, right? You add all the numbers up, you count how many there are, and then you just divide the total sum by the count. Easy. Now, here's what that exact same logic looks like in the Python language. First, we make a list to hold our numbers. Second, we create a new thing called average and tell the computer to calculate it by summing up our numbers and dividing by the length or count of that list. And finally, we just tell it to print out the result. See? Each line is a direct translation of one of our logical steps. And bam! Just like that, the computer runs our instructions and gives us the answer, 25.0. It's instant, it's perfectly accurate, and it's a super simple but powerful demonstration of how we turn human logic into machine action. Okay, so if you're feeling inspired and you're thinking, all right, I'm in, where do I even begin? Well, that's the perfect next question. In the world of data, the conversation almost always boils down to two main languages, R and Python. Here's probably the easiest way to think about them. R was literally built by statisticians for statisticians. It's a beast when it comes to deep statistical analysis and creating beautiful data visualizations. Python, on the other hand, is more of a general-purpose Swiss Army knife. It can do anything, and it's become an absolute powerhouse for things like machine learning, AI, and big data. But here's the crucial takeaway, the real secret. You don't have to choose one forever. In fact, many of the most effective data scientists out there are fluent in both. They use R for its specialized statistical firepower, and then they use Python for its incredible versatility. It's all about picking the right tool for the job. So, we've broken down what programming is, and more importantly, why it is such an essential skill for anyone working with data today. We've covered the what and the why, so the only question left is, are you ready to start learning the how?